So it's been well established for a long time now that adaptation is a key principle of how the brain processes sensory information. So when you walk into a smoky room like this one, for example, the initial smell of the smoke will be very powerful. After a few moments sat in that room, your olfactory system will adjust to the ongoing presence of the smoke and you'll notice it much less. What we were interested in doing in this study is examining if adaptation also occurs in the context of emotional decision making. Specifically, do we adapt to decisions that we initially find aversive? So this might be things like cheating, infidelity, and lying. Is it the case that the more we engage in these types of decisions, the less of an emotional response we have to them? And if that is the case, what's the effect on our behaviour? Is it the case that as our emotional response decreases, this allows us to increase the extent to which we engage in these types of decisions? So let's take Lance Armstrong as an example. Is it the case that the first time he decided to cheat on the Tour de France, he felt really, really bad about this? But the more he did it, the less bad he felt, and the more he was able to engage in this behaviour in the future. So how do we go about investigating this? So in this study, we asked 80 participants to come to the lab and play a game with another participant. Importantly, there were a number of different conditions, and in some of the conditions, we repeatedly presented participants with the opportunity to act dishonestly. So we could see how dishonesty changed over time. What we found is that participants initially started out being a little bit dishonest, but these lies got bigger and bigger as the game proceeded. So you can think of this as a slippery slope, where what begins as small acts of dishonesty escalate into much larger ones. So to try and uncover what was going on in the brain that might help us understand the mechanism behind this escalation, we then scanned a subset of participants using fMRI. Analysing this data, what we found is that as time went on, bold response in regions associated with emotion, particularly the amygdala, decreased the more participants engaged in lie telling. So this suggests that the act of telling lies actually reduces our brain's emotional response to dishonesty and encourages us to tell bigger lies in the future. In one analysis, we were actually able to show that decreases in brain activity actually predicted subsequent increases in dishonesty. So to try and summarise, I think this study provides the first empirical evidence that dishonest behaviour escalates when it's repeated. It suggests that reduced emotional brain responses can explain this increased willingness to deceive. And I think it highlights the potential dangers of engaging in small acts of dishonesty on a regular basis, because these can escalate into much larger ones further down the line.